Hello guys, welcome to another video. In the previous video, we learned about linear regression and we calculate the beta of a stock. In this video, we will be learning polynomial fit and we'll be making a regression line to find the density of water with respect to temperature. So the temperature will be our independent variable and the density will be our dependent variable. And we will make a polynomial fit and we'll try to make the best plot that passes through all the set of data points. So welcome to another video. The properties of water can be found out from the NIST website, which is a standard website, and from that website we will get the properties of water. So we will go to the NIST website and we will get the properties of water. So just go to the Google and type in NIST water properties and click on the first link. And this will take you to the page. So this is our website. So from here we need to get the properties of water. So we'll go to we'll select water. We'll go for a Celsius scale. For pressure, we are going to take the constant pressure properties. So you can either take a bar or atmosphere. So in this video, we will take atmosphere. So we'll take the properties at 1 atmosphere. And density, choose the units carefully. I'll go for the standard SI units. And viscosity, okay. Take isobaric properties. That is the properties at constant pressure. Go to and press to continue. Just click there. So you come to the next page. So in this page, first type in the pressure unit. So we choose atmosphere, so we give 1. So the properties will be at 1 atmosphere. And we can take the values from temperature from 5 degrees to 95 degrees. With an increment of 0.1. So why I choose between 5 and 95? Because most of our analysis will be dealing with water, and that will be in this region, because at 4 degrees Celsius there's a lot of change in the properties, and at 100 degrees there's a phase change, right? So there's a sudden change in properties. So I used to go for between 5 and 95. So depending upon your requirement, you can change the values, because if I took these values, you get the plot will be much smoother. So press for data. Okay. Now we can see the density, the variation of density. So we need the data, right? So go to view data in HTML table. So now we can see the data. Now we have to copy this to an Excel sheet. So select the data, select everything, and we just go to the last data here to select. So we'll scroll down and okay. So the last data corresponds to 95 degrees Celsius. So we have selected the data. Now just copy the data. So you can use Ctrl+C to copy the data. Now we are in our Excel sheet. Now we need to paste this data. So go to home, paste, special paste, go to text. Okay. Okay, now data is ready. I will edit the columns a little bit. Now we got our data. So you can see we got all the properties: temperature, pressure, density, volume, internal energy, entropy, enthalpy, and thermal conductivity and phase. So we'll be dealing with only density, and in the next video I will show you how to make an exponential fit for viscosity. So all other columns I will delete. Okay, now I have deleted all of the properties and I have just kept the temperatures, density and viscosity. So if you look at the temperatures, we got temperature from 5 to all the way down to 95, and we have the density values. So I'll copy this file to origin and we will do the fitting there. Now we are in origin and the X column represents the temperatures and the Y column represents the density. So first we'll go for a simple line plot. Select these two columns. We get a plot, symbol, line to symbol. Okay, so now we got our plot. You can see the line is very big, so we'll reduce the line size. We can make line and yeah, go for it. Okay, now we got our plot. So this represents the NIST values. Now we'll go and do a fitting polynomial. So now we'll go and do the fitting analysis. So now we got our plot. Now we will do the regression analysis and we make a polynomial fit. So in order to do that, just select a graph and go to analysis, go to fitting. So you can clearly see that it's not a linear fit. So we'll go for a polynomial fit. Analysis, fitting, polynomial fit, open dialog. Okay. So in polynomial fit, there are a couple of things. First one is the order of the polynomial. So usually higher the order of polynomial, the better. So first we will try a polynomial of order 2. The polynomial of order 1 is just a linear fitting. So polynomial of order 2 we will try. Just the rest of things are just default settings and we just give OK. So look at the plot. So yeah, the plot is almost good. And we look at the results. You can see that the R square value is close to 1.999968 and the residual sum of squares is 25.51757. So you can see the intercept and other values. So this plot is good. But again, to make it, so we are in our engineering field, right? So we'll go for a more accurate plot. So we'll try the polynomial fit with order 3. So I will delete all this. And okay, now we'll go for polynomial fit with order 3. Go to analysis, fitting, polynomial fit, open dialog. We'll change the values to 3 and we'll use the default settings. So you can see that the residual sum of squares has been reduced and the R square value is also higher than the previous one. Again, you can play with some of the values here. For example, the intercept. The intercept, you can actually fit the intercept. So I will show you how to just fix the intercept value. Again, I will delete all these things and we'll do from the start. So we'll delete all this. Okay, and again we'll select, go to analysis, fitting. Again, this time we'll go for polynomial fit of 3. In fit controls, we'll fix the intercept at. This value is close to the previous fitting value we got. So this will give more refined plot. Okay. So look at the magic. Our So we got an R square value of 1, so the plot is very good. And look at the residual sum of squares. It is 0.88383. That is very small. And we fix the value of intercept. And this is the equation. This is how we get a polynomial fit. So this is how we get a polynomial fit in origin. So I will edit the graph a little bit. So I have edited the graph a little bit, and so this is our final fitting. So you can see the equation I kept. So I will keep this in the description, so you can download this image, or you can do your own analysis based using this origin, and you will get your own you can find your own plot. So to conclude, we made the polynomial fitting. So the equation has been given here, and for this is for water in range between 5 degrees Celsius to 95 degrees Celsius with an R square value of 1. So if you have any queries, just feel free to write in our comment section, and we'll be happy to answer your queries. Thank you for watching this video. I will see you in another video.